Welcome to another teardown video. This time it's a digital pH meter 646 from Knick. I think this is a German brand, right? This is like lab equipment for either schools or research. It's sold by stores, and those guys are selling lab equipment and school equipment for all sorts of science labs. And this reveals that it's made in Germany, the Ausgang, and of course this one. So it's actually really neat design with this angled front. And it turns out that we can just power it up. And it's only drawing 2.3 watts. Really a little. And I think this is working. 0 and pH is just an interpretation of the input millivolts. And all this is scaling of the incoming millivolts. And again, another scale factor depending on the voltage. So all these three things is a scale factor from millivolt, but you can go directly into millivolts. And the first thing I did, just took my tweezers, just short circuit the input, and see, it's reading 0. So then I thought, hey, let's try and see if this millivolt thing is actually working. But now it's 1900. So that is a little bit odd. Because what I did is just took some banana connectors like this. And 10 ohms and 1K. So as far as I can see, if I adjust the voltage for 1 volt input, that means the 1 volt is over the 1K resistor, and the 10 millivolts here is over the 10 ohm resistor. Then we're actually done. Then I can just dial on the volts, right? So that means 10 millivolt. Oh, this is difficult. Yeah, okay, like this, right? So that is 10 millivolts. 2, 3, 4, 5, 6, 8 volts, 9, 10, 11, 12. So there's some sort of a limit when I input the voltage here for real, and now this is my 0, and even if I reverse the voltage input and then go up again to 50 millivolts, so it reads out pretty good, the millivolts correctly in positive and negative. But how is it possible for the thing to read a value that was higher? Before it was higher, right? What did I do? You see? But how can it read something more than the 100 when I know that I input more than 100 from the bananas? That is something I don't understand. See? 50. And then I crank up the input voltage. 10, 11, 12. See, there's some sort of and then I continue to input more and more and more, and then I go down to 8, 6, 5. That is strange. But anyway, let's go to pH. if we change the temperature compensation, that seems to be working. Delta pH. Okay, you can also dial this up and down. It also affects the, and this is of course also affecting the output. But this is a little bit confusing. How is that possible? So if I touch the input, I can read more. Duh. All right, let's see if we can get in. Maybe we don't. Okay, easy. It is the bottom. Huh, somebody forgot a screw. All right, I go and find a screwdriver. Don't you just love it when they're using specially designed screws for the task? So all screws are specially made. How cool is that? Oh, why didn't that open? Okay. That is nice. Oh, and this is some foam. It's soft, see? When I touch it, some soft, sticky, fantastic foam. And wow. So I guess the main transformator is up here. Everything is on one PCB in the front. We're going to open this. Could you just go away? All right, and the grounding here is done really nice with the front screws in all the corners. And that's pretty neat. Let's see how we get this PCB out. Note another thing. One of the side panels, there is a metal plate in here. And look at the grounding on the metal side. How nice is that? And they didn't do that on the other side. Really fantastic. I did remove the 4 screws, but nothing seems to be coming anywhere. I think we are stuck because of this screw. Why don't you just go out? Also, there's another thing I like to show here. This screw is for the bottom plate. Why is this so rusty? If you look carefully, maybe I can show it from this angle. I need to have the camera all the way on the edge. Can you see? The screw actually hits this track, which is grounding. Yeah, okay. So why don't you come out? Just doesn't happen. I need to be either more brutal or figure out how this is done. Hang on a second, we're gonna see. So sometimes when brutality doesn't seem to work, it's because you're doing something wrong. It's always the buttons or some hidden screw behind something. Maybe we need to get the front off. It's not coming off. See, it seems like it is really... Did I forget one more screw in here? Am I really that silly? Where are you? Okay, this time it was just a matter of a little bit more force. Wow, that is a beautiful display. And what have we got here? all analog. But what is that? They're doing some magic. And also look at that one. Oh, pretty cute. Let's look up the different ICs. There's an op-amp. Where's the... okay. The display magic is done in here. This is most likely just a normal voltmeter chip for LCD. So that is what it is, and then you can adjust. So where's the reference? Is it that one? Oh yes, it is. The 431. Come on, could you? Yeah. It's Yale 431, 2.5 volts reference. So this is what it is. So this is a nice multi-turn. Normal. Clickety clackety. Yeah, that's what it is. And a 12 volt regulator. Nothing more, nothing less. I think it's pretty sexy done with the side connectors to press onto the glass. Wow, that is pretty neat. And this transformator is really nice and cute. What is that one doing? RC725DE. What is that? All right. So that was it. A super fast teardown of this fantastic instrument. Those are really cute. Oh, look at that. Made in one piece. Of course, because its output, the output is millivolts. So you want really good banana plugs. Gold plated and all the super dupers. Just like we like it. And there's one more here. Even look at that connector. It is really nice. I like it. And here is the LCD display driver. Or should we just do it the friendly way? And look at this. This is really nice. A snap-on connector for LCD glass and then directly into pins. Here we go. Super cute.